Welcome to Science for Sleepy. Tonight, I want you to settle in, maybe dim the lights, and let your mind wander as we explore one of the most unsettling mysteries in science. Why haven't we met aliens yet? You live on a planet where scientists estimate there are more stars in the universe than grains of sand on every beach on Earth. Around those stars, billions upon billions of planets orbit. Many of those planets are not frozen wastelands or boiling infernos. They fall into what astronomers call the habitable zone, a comfortable band where liquid water could exist. Statistically, it feels almost impossible that life hasn't sprung up elsewhere, and yet the skies are silent. No alien spacecraft hovering above your backyard, no faint radio signals whispering from the stars, just an endless quiet void. Before we go further, let me pause here and ask you for a small favor. Could you slip down into the comments and tell me where you're watching this from and what time it is there? I love seeing the little map of our sleepy science community light up across the world. And while you're at it, go ahead and subscribe to Science for Sleepy. Think of it this way, if aliens do exist, they probably forgot to hit the subscribe button to the Great Galactic Newsletter, and look where that got them. Silence. Don't make the same mistake. Plus, we upload a new video every single day, so you can come back tomorrow for another calm journey through the mysteries of science. Now, let's return to the unsettling quiet of the cosmos. Back in the middle of the 20th century, scientists were brimming with optimism. In 1959, a pair of researchers, Giuseppe Cocconi and Philip Morrison, published a paper suggesting that advanced civilizations might broadcast radio signals across space. This sparked what would become known as SETI, the search for extraterrestrial intelligence. The idea was simple. If intelligent life exists, they should be out there transmitting, maybe even listening for us too. The equipment needed wasn't exotic. Radio astronomy was already advanced enough. So in 1960, a man named Frank Drake pointed a radio telescope at two nearby stars in an experiment he called Project Ozma. It was quiet, no signals, but no one was discouraged. After all, it was just two stars out of hundreds of billions. And yet, here's the uncomfortable truth. In the decades since, despite scanning the skies with ever more sensitive equipment, we've heard almost nothing. Just silence, punctuated by a handful of strange signals that never repeated. One of the most famous was the "wow" signal, detected in 1977, a burst of radio energy so odd that the astronomer Jerry Eman scrawled "wow" in the margin of the printout. But it never returned. Nothing else quite like it has appeared. Think about how strange that is. If the galaxy were teeming with civilizations, some of them older and more advanced than us, wouldn't we expect to notice something? A stray signal, a visible megastructure, some unmistakable sign of industry? Instead, it's as if the entire universe is keeping a secret. This silence isn't just puzzling, it's eerie. The physicist Enrico Fermi supposedly asked the question over lunch one day in 1950, "Where is everybody?" This casual remark grew into what we now call the Fermi paradox. If life is common, if intelligence arises naturally, then why don't we see evidence? The paradox is sharper when you consider time. Our galaxy is about 13 billion years old. Life on Earth has existed for over 3 billion years, but humans have only been around for a sliver of that mere hundreds of thousands of years. That means civilizations could have risen and spread across the galaxy millions or billions of years before us. Yet no one is here, and so the idea of the Great Filter was born. The Great Filter is not a telescope or a lab test. It is a concept, a way of framing the riddle. It suggests that somewhere along the path from lifeless rock to galaxy-spanning civilization, there is a barrier so hard to cross that almost no one makes it. Maybe life itself is nearly impossible. Maybe the leap from single-celled organisms to complex ones is rare. Maybe intelligence usually destroys itself before it can reach the stars. Wherever this filter is, its existence could explain the silence we hear when we tune our antennas to the sky. The idea is both comforting and terrifying. Comforting, because if the filter is behind us, if the hardest steps are already in Earth's past, then perhaps we are rare and precious, a civilization that managed to make it. Terrifying, because if the filter lies ahead, it means our greatest challenges are yet to come, and most civilizations never survive them. This is where the story deepens, because the Great Filter isn't just about aliens, it's about us. It forces you to ask, what if the reason we haven't met anyone is that civilizations like ours tend to vanish quickly, extinguished by their own inventions, by wars, by resource collapse, by accidents? When you look up at the night sky, twinkling with stars that may host Earth-like worlds, you're not just wondering about life out there, you're glimpsing a possible reflection of our own future. One unsettling angle is the math itself. Scientists have tried to formalize the question using something called the Drake equation. It's not a formula that gives a single neat answer, but rather a framework of probabilities. How many stars form each year? What fraction have planets? How many of those planets are habitable? How many give rise to life? And then intelligent life. How long does a civilization broadcast before it disappears? Each factor is uncertain, and small changes swing the outcome wildly. One set of assumptions gives you a galaxy buzzing with civilizations. Another set leaves us tragically alone. And every time we look and fail to find signals, the odds shift a little more towards silence. But here's the thought I want to leave you with at the end of this part. If you step outside tonight and gaze at the stars, you are looking into a universe that should, by sheer numbers, be overflowing with life. Yet all the evidence so far points in the opposite direction. So the question lingers like an unanswered whisper. Is the Great Filter behind us, or still waiting ahead? When you hear the word paradox, you might think of a puzzle or a contradiction, and that is exactly what the Fermi paradox is. You have a galaxy so old and so full of stars that life seems not just possible, but inevitable. Yet when you listen for it, watch for it, search for it, nothing appears. Imagine standing in the middle of a vast desert, knowing there are millions of other people supposedly out there, but you cannot see a single footprint or hear a single voice. That is the paradox. To understand it more clearly, let's start with a thought experiment. Picture the Milky Way galaxy, a swirling disk of hundreds of billions of stars. If just one in every 10 of those stars has a planet in the habitable zone, then you are already talking about tens of billions of potentially life-friendly worlds. Now, imagine that life emerges on even a tiny fraction of those worlds, say 1 in 1,000, that would still leave millions of planets with life. And if even a fraction of those evolve intelligence and technology, then you should expect thousands of civilizations. With thousands of civilizations, at least some should be detectable. Maybe through radio waves, maybe through the faint glow of their cities, maybe through strange engineering projects on the scale of stars. Yet here you sit, in the 21st century, listening, looking, finding nothing but static. This silence is what gives the Fermi paradox its sting. If civilizations are possible and plentiful, why is the night sky so empty of signs? When Enrico Fermi raised the question back in the middle of the 20th century, it was over a casual lunch with colleagues. The legend says he asked simply, "Where is everybody?" But that offhand question has haunted scientists ever since. It hangs in the air because you cannot easily shrug it away. If the universe is fertile ground for life, then the lack of evidence is itself evidence of something strange. One way to understand it is to compare timelines. The Earth is about 4.5 billion years old. Humans, as a species, have only existed for a couple 100,000 years, and modern technology is only a few centuries old at most. If intelligent life were common, then some civilizations would surely have had millions of years to spread, to colonize, to leave marks. Millions of years is such a vast stretch of time that even slow-moving expansion would fill the galaxy. You could imagine self-replicating spacecraft seeding stars like dandelion fluff drifting in the wind. In theory, the entire galaxy could be explored or settled in a time frame that is short compared to its age. And yet, when astronomers look, they do not see evidence of this cosmic gardening. There have been explanations, of course. Some suggest maybe civilizations are out there, but they are quiet on purpose. Perhaps they are cautious, avoiding broadcasting their presence in case hostile neighbors are listening. Others suggest maybe we are listening the wrong way. Perhaps advanced civilizations communicate in ways that do not rely on radio, ways we cannot even imagine. There is also the possibility that life is so alien we would not recognize it even if it were right in front of us. After all, our definitions of life are based on Earth's biochemistry, carbon, water, DNA, but the universe could harbor life that works on entirely different principles, slipping past our instruments like shadows. Still, there is a deeper, darker possibility. Maybe there really is no one else. Maybe life is far rarer than we ever dreamed. This is where the idea of the great filter returns with force. The paradox forces you to consider that perhaps the silence is not an accident, not a trick of perspective, but the natural state of things. The universe might be mostly dead, and the steps that brought life to Earth might be vanishingly unlikely elsewhere. To feel the weight of this, it helps to remember how fragile your own history is. The Earth itself has been hit by extinction events that nearly wiped life out. Around 2.5 billion years ago, the so-called Great Oxidation Event filled the atmosphere with oxygen, which sounds good to you now but was toxic to many early microbes. Hundreds of millions of years ago, volcanic eruptions, asteroid impacts, and climate shifts have all threatened to erase the progress of evolution. Out of these countless turns of fate, life continued, adapted, and eventually produced you. The odds of each step may be slimmer than you realize. The paradox is not just a question about others. It is a mirror held up to the improbability of your own existence. Now, let's simplify all this down, because paradoxes can easily feel abstract. Imagine you are at a gigantic party, the largest you could ever imagine. Billions of invitations went out. You arrive, and the house is huge, with endless rooms and long hallways. You expect to hear voices, laughter, music. But as you wander, it is quiet. The rooms are empty. The food is untouched. You begin to wonder, did anyone else ever get the invitation? Or maybe everyone left long before you arrived? That is the Fermi paradox in human terms. It is the mystery of showing up at the cosmic party and finding yourself alone. Even the boring details matter here, and they matter more than you might think. For example, when scientists point radio telescopes at the sky, they are not scanning all frequencies at once. They often pick narrow bands of the spectrum, focusing on windows where signals would be most efficient to send. The most famous is called the water hole, a quiet band between hydrogen and hydroxyl emissions. The reasoning is simple. If you were an alien wanting to announce yourself, you would likely choose a frequency that stands out against the natural cosmic background. Yet decade after decade, scan after scan, nothing shows. This absence is not dramatic, but it is significant. Every silent observation deepens the paradox. Even more quietly troubling is the fact that our own signals, the television and radio broadcasts we once imagined leaking out to the stars, are fading. In the early days of broadcasting, signals were powerful but also noisy, spilling into space in all directions. Today, with digital technology and satellites, much of our communication is tightly beamed or encoded, less likely to escape Earth. That means, if other civilizations rely on similar technology, their signals might be just as faint, lost in the cosmic noise. This makes the paradox even sharper. The more advanced you get, the harder it becomes to notice you. Perhaps the galaxy is full, but everyone is whispering so softly we cannot hear. there is also history to consider. In the 1970s and 80s, scientists like Carl Sagan popularized the idea that contact was not just possible but likely. Optimism was high, fueled by the rapid pace of discovery. But as decades passed and the search turned up empty, the mood shifted. Today, the silence weighs heavier. It suggests that maybe the odds are stacked against us, or that we are too early or too late in the game. This leaves you with an unresolved question, one that lingers in the quiet after the telescope powers down. Is the paradox telling you that life is rare, or is it warning you that civilizations like ours are fragile? That question is the heart of why the Great Filter matters. So as you lie there listening, drifting closer to sleep, think about this. If you could look out across the galaxy tonight, past the stars and the dust, would you see countless civilizations flickering like city lights on distant shores? Or would you see only darkness, with Earth as a lone lantern? So, what exactly is this thing people call the Great Filter? At its heart, it is not a single object or event. It is more like a doorway that nearly every civilization fails to pass through. Imagine a long, winding path that leads from the birth of a planet all the way to advanced spacefaring life. Along this path are countless hurdles. The Great Filter is the idea that at least one of these hurdles is so high, so nearly impossible, that almost no one makes it to the other side. That is why you see silence in the skies. To make sense of it, let's break that long path down into simple steps. First, you need a planet. Not just any planet, but one that sits in the right kind of orbit close enough to its star to be warm, far enough not to boil. Next, you need the right ingredients for life: water, carbon, energy. Then, you need the spark of life itself. After that, life has to evolve into something more complex than a soup of single cells. Eventually, those organisms must develop intelligence, tools, and technology. Finally, they must survive long enough to spread into space. At each of these steps, something could go wrong. Perhaps most planets never form at the right distance. Perhaps chemistry rarely produces the first living cell. Perhaps complex multicellular life is almost impossible. Or perhaps civilizations tend to destroy themselves before they spread. If any one of these steps is nearly impossible, then that step becomes the Great Filter. It is like a narrow gate in the middle of a wide road. Everyone approaches it, but almost everyone fails to pass through. Think of it this way. If you line up a row of dominoes stretching across the universe, the Great Filter is the domino that refuses to fall. No matter how many times you set the chain in motion, the collapse stops there. That is why, even though the universe should be full of life, it looks empty. The filter has stopped them all, but here is where the idea takes a darker turn. Scientists debate whether the Great Filter lies in our past or our future. If it is behind us, then perhaps we are rare survivors. Maybe life itself is the filter. Perhaps the very first cell was such an unlikely event that it only happened once in the galaxy. That would mean we are lucky, unbelievably so. Alone, but lucky. On the other hand, if the filter lies ahead of us, then we are in danger. That would mean life is common, intelligence is common, but every civilization eventually collapses before reaching the stars. The filter, in that case, is not the first spark of life, but the last gasp of civilization. Nuclear war, runaway technology, environmental collapse, or disasters. We cannot yet imagine whatever it is. It ends nearly everyone before they can spread. If that is true, then the silence of the universe is a warning. It is the graveyard hush after billions of failed experiments. To put this in more human terms, imagine you are walking down a long hallway lined with doors. Each door represents a stage of development. Behind one of the doors, a trap is waiting. Some doors you open safely, others too. But eventually, if the trap door is still ahead of you, it will spring shut. If the trap is behind you, then you have already survived it. The The trouble is, you cannot know for sure where that trap lies. That uncertainty is the unsettling part of the Great Filter. Let's bring in some history here. In the 1990s, economist Robin Hanson helped popularize the term Great Filter. His argument was straightforward. The silence of the skies suggests one of the steps to advanced civilization is almost impossible. Otherwise, the galaxy would be filled with evidence of life. Hansen laid out the sequence from planet formation to space colonization and asked, which of these steps is nearly impossible? His writing forced scientists to think not just about aliens, but about humanity's own trajectory. When you hear it in this calm way, it may sound abstract. So let's ground it with some examples. On Earth, it took billions of years for life to go from simple single-celled organisms to anything more complex. Single cells appeared quickly, maybe within a few 100 million years of Earth cooling down. But then, for over 2 billion years, almost nothing happened. Life remained microscopic, clinging to oceans, dividing and consuming, but not becoming anything you would notice without a microscope. This long delay could be a clue. Maybe the leap to complex life is incredibly rare. If that is true, then perhaps the Great Filter is behind us. But here is the catch. Once complex life did evolve, it exploded in diversity. Fish, plants, insects, dinosaurs, mammals. Intelligence followed eventually, though slowly. If the filter was the leap to complexity, then we might already be past the hardest step. That would be comforting. Yet it is equally possible that the real test still lies in the future. After all, humans have had advanced technology for barely more than a century. Nuclear weapons have existed for less than a century. Climate change has been understood for less than a century. Artificial intelligence is still in its infancy. If most civilizations reach this level and then collapse under the weight of their own power, then the filter is still waiting. There is another way to think about it. Picture a huge mountain range. Each valley is a step on the path of life. Some valleys are easy to walk through, others are blocked by cliffs. If civilizations get stuck in the valleys, they never reach the next one. The Great Filter is the steepest cliff of all. Humanity has climbed some already, but has the hardest climb been conquered? Or is it the one directly ahead? This framing is why the idea of the Great Filter is more than just science fiction speculation. It forces you, as a listener, to consider not only what is possible in the universe, but what is likely. It asks, what if our silence is not an accident, but the rule? What if the cosmos is filled with planets that almost succeeded, but failed at one critical step? What if we are walking toward the same fate? Even in its most boring details, the filter matters. For example, Earth's atmosphere remained oxygen-poor for billions of years, which might have stifled the rise of complex life almost indefinitely. Or consider plate tectonics, the slow churning of Earth's crust that recycles nutrients and stabilizes climate. Without it, maybe life would stagnate or collapse. These are not dramatic details, but they are quietly decisive. Each represents a possible filter that most planets may never pass. And then there are the filters still ahead of us. Think about how fragile global systems are. Modern civilization relies on stable climates, stable energy sources, stable politics. Disruptions in any of these could unravel progress. The idea of nuclear war, once at the front of every newspaper in the 1960s, still hangs over us. Pandemics remind you of how vulnerable global society can be. Climate change pushes ecosystems toward tipping points. Artificial intelligence could either transform society or destabilize it. These are dull in the sense that they unfold slowly, with graphs, reports, and data points. But in the context of the Great Filter, they are monumental. So the Great Filter, when you peel away the mystery, is not one thing but a series of questions. Which hurdles are nearly impossible? Which ones are behind us? And which ones lie ahead? And above all, are we one of the rare civilizations that might survive long enough to cross into the stars? Or are we just another in a long line of doomed attempts? As you drift into sleep with these thoughts, imagine the billions of silent planets out there. Some of them may have had oceans, mountains, forests, even creatures that crawled or flew, but none made it past the filter. The silence you hear when telescopes sweep the skies may be the echo of their absence. And so, the question lingers like a whisper at the edge of your mind. Have we already passed the great filter, or is it waiting just around the next corner? If you want to understand why the great filter is such a haunting idea, you need to step all the way back to the early universe. Close your eyes for a moment and picture it. Not the familiar starry night sky, but a universe before stars even existed. 13 billion years ago, there were no galaxies, no planets, not even dust as you know it. There was only hydrogen, helium, and a trace of lithium, simple gases adrift in a cooling void. For hundreds of millions of years after the Big Bang, the universe was dark. Astronomers call it the cosmic dark ages. Eventually, gravity began to work its quiet magic, pulling those gases together into clumps. The first stars ignited, massive and short-lived, burning hotter and faster than anything around today. They fused elements in their cores and exploded in supernovae, scattering heavier atoms, carbon, oxygen, iron across space. It was only after several generations of such stars that enough heavy elements existed for rocky planets to form. Without that long process of stellar birth and death, Earth could not exist, and you would not be here to wonder about the great filter. Now pause to think about the odds in this early story. Stars had to form in just the right way, massive enough to forge heavier elements, but not so massive that they collapsed into black holes without spreading those elements around. Galaxies had to organize themselves into stable structures, spiral arms rich in star formation. Among all those stars, some had to form planetary systems with rocky worlds. And within those rocky worlds, at least one needed to orbit in a band where water could remain liquid. Each step might sound simple when told as a bedtime story, but each is a narrowing funnel, a chance for failure. When Earth finally formed around 4.5 billion years ago, it was not the friendly blue marble you see from space today. It was a hellish landscape, hammered by asteroids, drenched in volcanoes, and wrapped in a toxic atmosphere. Yet somehow, in that chaos, life appeared. The earliest traces of microbial life show up in rocks about 3.5 billion years ago. Think about that life began relatively quickly after Earth cooled. But here is where the mystery deepens. If life can appear so quickly, why don't we see it everywhere else? Perhaps those early microbes were the easy part, and the real filters came later. Or perhaps Earth itself is extraordinary, a rare oasis in a mostly barren universe. Let's slow this down and look at some of the duller but essential details. Earth's orbit is almost circular, which keeps its climate relatively stable over long stretches of time. If it were highly elliptical, swinging closer to the sun and then far away, the planet might swing between boiling and freezing in ways life could not endure. Earth also has a large moon, unusual compared to most planets. That moon helps stabilize the planet's tilt, preventing wild shifts in climate that could have reset evolution again and again. Then there is Jupiter, the massive gas giant whose gravity helps shield Earth by pulling in comets and asteroids that might otherwise smash into us. These are the boring, quiet factors that rarely make headlines, but without them, Earth might have been uninhabitable. And then there is water. Earth did not have oceans from the start. Much of its water may have arrived from icy comets or asteroids colliding with the planet in its early years. Without those deliveries, the surface might have remained a dry desert. Even the chemistry of the oceans mattered. Too salty, too acidic, too hot, and the fragile molecules of life would never have survived. You can begin to see how fragile the conditions really were. If the great filter exists, perhaps it hides in these early stages, hidden not in the drama of nuclear weapons or artificial intelligence, but in the quiet chemistry of a newborn planet. Billions of planets may have formed in the galaxy, but how many had the right orbit, the right moon, the right balance of gases and water? The silence of the universe might be telling you, very few. It is also worth noting how Earth almost failed before it began. In its first billion years, it endured what scientists call the late heavy bombardment, a period when massive impacts scarred the surface. Entire oceans may have boiled away under the heat of collisions. If life had started before then, it might have been erased, forcing the process to begin again. That life managed to take hold despite this chaos is remarkable. You could even think of it as the first evidence that life is stubborn, clinging to cracks and crevices, waiting for calmer days. But was this stubbornness unique to Earth, or common across the cosmos? That is the question that turns over in scientists' minds. Astronomers now look at exoplanets, planets orbiting other stars for clues. Thousands have been discovered, and a surprising number orbit in the so-called habitable zone. Some are rocky, some are roughly Earth-sized. This should be encouraging. It means the universe is not short on worlds where life could, in theory, exist. And yet, so far, not one shows clear signs of biology. We search for atmospheres rich in oxygen, methane, or other gases that might betray life. The search is still young, but the silence continues to stretch. There is another quiet but important factor: time. The early universe may simply have been too hostile for life. Radiation levels were higher, heavy elements rarer, cosmic collisions more common. Perhaps intelligent civilizations are still only beginning to emerge, scattered here and there, too young for their signals to have reached us. In that case, the filter may not be absolute, just a delay. We might simply be early, one of the first to awaken. That thought is both comforting and lonely. Imagine standing on a beach before anyone else has arrived, hearing only the waves and wind. If the great filter lies in these early steps, then humanity has already crossed it. That would make us rare, perhaps unique. It would mean that all the fragile alignments, the right star, the right orbit, the right moon, the right delivery of water, were extraordinary strokes of fortune. If that is true, then the silence of the universe is not a warning but a confirmation. We are the lucky ones, the improbable survivors. But luck is a dangerous comfort. It tempts you to relax, when perhaps caution is wiser. As you rest and listen, think of all those other worlds out there, spinning silently around their stars. Some might be scorched wastelands, some frozen tombs, some simmering with chemical soups that almost but never quite cross the threshold into life. They are the near misses of the universe, silent testimonies to how rare your own existence might be. And so the question whispers again: did we already pass the great filter in those fragile early steps? Or is the true barrier still waiting for us, hidden in the future? When you picture life, you probably imagine forests, oceans, animals, and people. But for most of Earth's history, life was nothing more than tiny, single-celled organisms. These microbes ruled the planet for billions of years, quietly eating, dividing, and releasing gases into the atmosphere. They were successful in their simplicity, and in truth, they didn't need to evolve into anything more. Which raises a strange question. If simple life is relatively easy to produce, why did it take so unimaginably long for complex life to appear? And if it took so long here, maybe it rarely happens anywhere else. The leap from single-celled to multi-celled life might itself be a great filter. On Earth, that leap only happened about 600 million years ago, long after life began. Imagine that. For nearly 3 billion years, cells floated alone, content with their simple existence. Then, almost suddenly in geological terms, they began sticking together, cooperating, and forming larger bodies. The reasons are still debated. Perhaps oxygen levels in the atmosphere finally reached a threshold that made more complex metabolisms possible. Perhaps environmental stress forced cells to cluster together for survival. Whatever the cause, this shift was not guaranteed. And even after multicellularity began, the path forward was not smooth. Early experiments in complex life sometimes fizzled out. Some organisms may have been fragile, others poorly adapted, many wiped away by environmental shifts. Only a few lineages managed to persist, eventually giving rise to the strange menagerie of creatures you might remember from textbooks: trilobites, jellyfish, early worms, and then, much later, the ancestors of fish, reptiles, and mammals. Now think about intelligence. It is easy to assume that evolution always trends toward smartness, toward building beings capable of thought and culture. But most life has no need for intelligence. Trees thrive without it. Insects dominate ecosystems without it. And even jellyfish, with no brains at all, still fill oceans today. Intelligence is costly. It requires energy, large brains, complex nervous systems, long childhoods to learn, and social structures to sustain. Out of the billions of species that have lived on Earth, only one has developed the kind of intelligence that builds telescopes and wonders about aliens. Just one. That is a sobering thought. In fact, many scientists suggest that intelligence may not be inevitable at all. Dinosaurs ruled Earth for over 150 million years, far longer than humans have existed. They were highly successful, spread across the globe, diverse in form and size, and yet none developed technology. They did not build cities, radios, or spacecraft. They did not need to. Nature rewards survival, not philosophy. So the rise of humanity might be less destiny and more accident. There were also moments when evolution could have gone another way. For example, early mammals lived in the shadows of dinosaurs, small and unremarkable. It was only after an asteroid impact 65 million years ago wiped out the dinosaurs that mammals had a chance to flourish. Without that asteroid, there might never have been an opportunity for your lineage to rise. The great filter might not always be about chemistry or biology. Sometimes it is sheer luck, the roll of cosmic dice. Even within human evolution, the path was delicate. Our ancestors walked upright in Africa millions of years ago, but it took countless generations of trial and error for traits like larger brains, tool use, and complex language to emerge. Other hominin species, Neanderthals, Denisovans, and others shared the earth with us. They too had intelligence, but their branches of the tree ended. Why? The reasons remain uncertain. Was it climate shifts, disease, competition, or simply chance? If multiple human-like species rose and fell before us, maybe our survival is not inevitable but precarious. And even once humans achieved intelligence, civilization itself was not guaranteed. For tens of thousands of years, people lived as hunter-gatherers, moving with the seasons, surviving without cities or writing. The invention of agriculture only about 10,000 years ago transformed everything. Suddenly, humans could settle, grow food in surplus, and support larger populations. From there came villages, kingdoms, empires, and eventually the modern world. But again, agriculture was not inevitable. Some societies never adopted it fully, others collapsed after trying. Imagine if agriculture had never taken root. Human life would look profoundly different. Now pause and notice the pattern. Each stage in this story, multicellular life, intelligence, civilization, is not guaranteed. They are improbable steps, bottlenecks, in the long chain of existence. This is where the great filter might reside, hidden not in one giant obstacle but in a series of fragile thresholds. Life may often begin, but only rarely does it cross enough thresholds to reach the point of building radios and rockets. That could explain why the stars remain silent. Let's add one more layer of fragility. Extinction. Earth has endured at least 5 major mass extinctions, events so severe that much of life was wiped out. The asteroid that ended the dinosaurs was only one of them. There was the Permian extinction, about 250 million years ago, when nearly 90% of species vanished. There were ice ages, volcanic winters, and shifts in climate that tested life repeatedly. Each extinction reset the clock, forcing survivors to rebuild. Humanity itself has faced near misses. Genetic studies suggest that tens of thousands of years ago, the human population shrank to only a few thousand individuals. A slightly different outcome, and you would not be here at all. You might wonder, if life is so fragile, how did we make it this far? Perhaps the answer is persistence. Life may be fragile in any given moment, but it is also stubborn, endlessly trying again. Still, the silence of the cosmos suggests that many planets may not have survived their own gauntlets of chance. Most may have stumbled at one of these steps, their experiments in complexity cut short. What makes this perspective quietly unsettling is that humanity's own existence could be less secure than it feels. If intelligence is rare, if civilization is fragile, then our survival into the far future is not guaranteed. We may already have passed through many filters, but how many remain ahead? That is the question that hangs in the quiet of the night. So tonight, as you drift into sleep, consider the improbabilities that led you here. A planet with liquid water, a stable orbit, a shielding moon, microbes that learned to cooperate, brains that grew larger, ancestors who survived disasters, and civilizations that found ways to persist. Each step could have failed. Each step was fragile. And if so many steps were fragile, then what are the chances that another planet, circling another star, has managed to pass them all? Perhaps the silence is not a mystery at all, but a mirror. It is not that aliens are hiding. It is that the pathway to intelligence is like threading a needle in the dark, nearly impossible to complete. You, listening now, are part of one of the rarest outcomes the universe has produced. But if that is true, another question lingers in the air. What happens next? Have we cleared the hardest obstacles, or is the great filter still waiting ahead, unseen but inevitable? You live in a world where skyscrapers touch the clouds, satellites circle overhead, and tiny devices in your pocket connect you instantly to people across the globe. It feels permanent, doesn't it? But history whispers a different story. Civilizations rise, shine brightly for a time, and then fade into dust. The ruins of ancient empires stand as quiet reminders. What feels solid now is often fragile when you zoom out over centuries. And this fragility matters deeply when we think about the Great Filter. Take Mesopotamia, often called the cradle of civilization. In the Fertile Crescent between the Tigris and Euphrates rivers, people first built cities, created writing, and organized laws. It was one of humanity's great leaps forward. But the rivers also flooded unpredictably. Soil grew salty from irrigation, and wars between city-states weakened the region. Over time, the brilliance dimmed. Mesopotamia did not vanish entirely, but its empires fell one by one, leaving behind clay tablets and crumbling ziggurats. Or look to the Mayan civilization in Central America. They developed advanced calendars, mathematics, and impressive cities with towering pyramids. Yet droughts, resource strain, and internal conflict eventually fractured their world. Many cities were abandoned, swallowed by jungle. For centuries, their great achievements lay hidden, forgotten until explorers stumbled upon them again. The Roman Empire, too, seemed unstoppable at its peak. Roads spanned continents, aqueducts carried water for miles, and Roman law shaped daily life across a vast territory. But corruption, overexpansion, economic troubles, and invasions chipped away at its strength. By the 5th century, the Western Roman Empire had collapsed, leaving Europe in what historians call the Dark Ages. These stories matter because they reveal a pattern. Complex societies are fragile. They rely on stable climates, abundant resources, and cooperation among people. But climates shift, resources dwindle, and human cooperation is often tenuous. Civilization, for all its might, rests on surprisingly delicate foundations. Now widen the lens. If civilizations on Earth rise and fall so easily, what does that mean for civilizations beyond Earth? Imagine an alien society that reaches the point of building cities, technology, and space travel. They too would need stable conditions. They too would face pressures of population, resources, and conflict. If the rise of civilizations is common, perhaps their collapse is even more common. In that case, the great filter might not be behind us, in the chemistry of life, but ahead of us in the fragility of civilizations themselves. Consider technology. It is both the greatest tool of survival and a potential source of collapse. Nuclear weapons, developed in the 20th century, hold the power to destroy human civilization in hours. Climate change, fueled by industrial progress, threatens to destabilize the very environment that sustains us. Artificial intelligence, biotechnology, and other innovations carry promises, but also risks. Each new technology is a double-edged sword capable of lifting us higher or cutting us down. Perhaps many civilizations before us reached a similar point, only to stumble. There is a quiet lesson here in the boring details. Societies depend on supply chains, infrastructure, and cooperation that you rarely notice. Your electricity depends on grids of wires and transformers. Your food depends on farmers, transport networks, and stable weather. Your medicine depends on global trade and functioning governments. Each system feels invisible until it falters, and when many falter together, collapse can come quickly. Past civilizations fell not just from grand catastrophes, but from slow erosion of these background systems. If the great filter is ahead, it may not look dramatic at first. It may arrive as small cracks in the systems we take for granted. And think of communication. Civilizations that fall often leave behind echoes, ruins, artifacts, stories, but little that lasts. Imagine if humanity vanished tomorrow. Satellites would orbit for decades, maybe centuries, before burning up. Radio signals would continue to drift into space, but they would weaken and dissolve into cosmic background noise. In a million years, almost all trace of human civilization would be gone, save perhaps for a few stubborn monuments like the pyramids. From an alien perspective, Earth might look forever silent, even if a vibrant civilization once existed. Perhaps the stars are full of such silences, worlds where societies rose, faltered, and disappeared before anyone could notice. This idea is not just speculation. Scientists who study the Fermi paradox, the puzzle of why we see no evidence of aliens, sometimes call this the Great Silence. Civilizations may exist, but they may not last long enough to overlap with one another. The universe is vast, and the timing must align perfectly for one society to detect another. If most collapse quickly, the odds of overlap shrink to nearly zero. Let's not forget Earth's near misses. In the 20th century, during the Cold War, nuclear war seemed dangerously close. Entire strategies, like mutually assured destruction, balanced on the idea that if one nation launched weapons, the other would retaliate, and both would be destroyed. Humanity came within minutes of catastrophe on more than one occasion. One Russian officer, Stanislav Petrov, once ignored a false alarm of incoming nuclear missiles, preventing retaliation that could have triggered global devastation. His choice, calm in the face of duty, may have saved the world. Think about that civilization balanced on a single person's decision. If filters exist, they may sometimes take the shape of human judgment under pressure. The lesson runs deeper. Survival is not just about technology, but about wisdom. A civilization might be intelligent enough to build rockets, but not wise enough to avoid self-destruction. Intelligence alone is no guarantee of longevity. Perhaps the stars are full of brilliant species that reach the point of technology, only to fail the test of restraint. So where does that leave you? If the great filter lies in civilization itself, then humanity may be approaching it. We may be at the knife's edge, where our tools are powerful enough to destroy us but not yet guided by the wisdom to prevent it. The silence of the stars could be a warning. Countless others may have reached this moment and faltered, and yet there is hope. Each collapse in history also left lessons. Rome fell, but its laws and architecture inspired later generations. The Mayans faded, but their descendants carry on their culture. Even in collapse, knowledge can persist, and sometimes it builds anew. Humanity today has one advantage past civilizations never had: a global perspective. For the first time, you can see the Earth as one planet, fragile and blue, hanging in the black of space. Perhaps that awareness can help us avoid the pitfalls others may have faced. Still, as you lie in the quiet of night, listening, you must wonder, are we approaching the great filter now? Or have we already slipped past it without realizing? Will humanity learn to build wisely, or will our silence one day join the countless others scattered through the stars? Up to now, you've heard two possible stories. One is comforting. Maybe the hardest part of existence is already behind us. Maybe the fragile steps of chemistry, biology, and evolution were the great filter, and humanity is rare precisely because we survived them. But there is another story, one that lingers like a shadow. It says the great filter is not behind us at all. It lies ahead, waiting. This idea is unsettling because it turns silence into a warning. If the universe is teeming with planets, and if life tends to emerge easily, then there should be countless civilizations scattered across the stars. Yet we see none. No signals, no artifacts, no visitors. That silence suggests something stops them before they can spread. And if it stops them, why would we be different? Imagine it like a trail in a forest. You've been walking for hours, and the path seems clear. But scattered on the ground, you notice broken equipment, tattered clothing, faint signs of travelers who came before you. None of them made it to the end. The silence of the forest does not mean the path is empty, it means it may be deadly. You just haven't reached the danger yet. So what could this future filter be? Scientists and philosophers have floated many possibilities, some mundane, others chilling. One obvious candidate is self-destruction. Civilizations may become powerful enough to destroy themselves, long before they become wise enough to prevent it. Nuclear war is one example. Environmental collapse is another. Climate change, resource exhaustion, pandemics, engineered by accident or design, each is a potential trigger. A civilization might build shining cities and advanced technology, but if it cannot stabilize itself, its glory could vanish in a blink. But there are stranger possibilities too. The filter could be built into the very physics of the universe. Perhaps faster than light travel is truly impossible, and no civilization can ever spread beyond its home system. Maybe interstellar colonization is so difficult, so slow, that most societies run out of time before they succeed. Stars change, planets warm or freeze, and the fragile window of habitability closes. Civilizations may survive for a while but remain trapped, silent, and isolated. There is also the possibility of discovery, not the discovery of salvation, but of danger. Imagine a civilization that grows curious and begins scanning the cosmos, broadcasting signals into the void. One day, those signals reach the wrong ears. Perhaps there are predators out there, civilizations that survived by ensuring no competitors could rise. This is the dark forest hypothesis, named after the idea that the universe might be like a silent forest at night, where every creature hides for fear of being hunted. If that is the case, then silence is not just an absence, it is a survival strategy. Of course, these ideas stretch into speculation, and perhaps they sound dramatic, but the quiet truth is that humanity does not yet know what its own future holds. Look back, only 100 years. In the early 20th century, airplanes were just beginning to fly. Radio was a new invention, and nuclear energy was not even imagined. Now, in just a few generations, humanity holds the power to alter the climate, to destroy itself in hours, and to reach beyond its planet. Project forward another few centuries, and you begin to feel the uncertainty. Can a species handle power that grows faster than its wisdom? Sometimes, When scientists discuss the Great Filter, they mention a peculiar tension. If we find life elsewhere, even simple microbes on Mars or beneath the icy crust of Europa, it might actually be bad news for us. Why? Because if life is common, then the filter must come later, at the stage of intelligence or civilization. But if life is rare, if Earth is the only oasis, then perhaps we already passed the hardest test. So, in a strange way, finding an empty universe would be comforting, while finding life might hint that our own future is far more precarious. You might also think about the speed of progress. Civilizations could collapse not because of one dramatic disaster, but because of creeping decay. Resources run low, social trust erodes, political systems fracture, progress slows, stagnates, and then reverses. Over centuries, knowledge can be lost, cities abandoned, and memory of technology fade. The Great Filter might not be a sudden blow, but a slow unraveling. Silent worlds could be littered with ruins, their inhabitants reduced to simpler ways of life, leaving no sign for the stars to notice. There is another possibility, one that is both eerie and strangely peaceful. Perhaps civilizations survive but choose not to expand. After all, colonizing space may be expensive, dangerous, and less appealing than simply perfecting life at home. They might turn inward, building virtual worlds, digital paradises, or self-contained systems. To outsiders, they would be silent, invisible, uninterested in communication. If so, the Great Filter is not destruction but disinterest. Civilizations might survive, but they vanish into their own inward universes, leaving the cosmos quiet. This thought raises an even deeper question. Is survival the same as flourishing? Humanity might avoid nuclear war, stabilize the climate, and continue for thousands of years. But if we turn inward, retreating into simulations or self-contained worlds, would anyone out there even know we existed? The universe might already be filled with thriving, inward-looking civilizations that have left the cosmic stage. Silence, in this case, would not mean death, but withdrawal. As you listen, drifting towards sleep, you may feel the weight of this mystery. If the Great Filter is still ahead, then we are walking toward it blindly, not knowing what form it will take. Will it be sudden, like a thunderclap, or gradual, like the slow dimming of a light? Will it come from outside, in the form of cosmic limits, or from within, in the form of our own choices? The silence of the stars does not answer these questions. It only leaves you with the uneasy awareness that something may be waiting. And so you must ask yourself, are we early survivors in a universe still waking up? Or are we naive wanderers on a path that countless others have already walked to their end? Picture yourself lying in a quiet room. The world around you is still. No voices, no footsteps, just silence. Now imagine that room is not a room at all, but the universe. Everywhere you look, there are stars, billions of them, arranged into billions of galaxies. Each star is a potential sun, each sun perhaps with planets, some rocky, some icy, some in the warm band where liquid water could exist. By sheer numbers, there should be countless Earth-like worlds. And yet, when we listen, really listen, we hear nothing but static. That silence is the heart of the Great Filter problem. The paradox was first made famous in the 1950s by physicist Enrico Fermi, who supposedly asked during lunch, "Where is everybody?" It is such a simple question, but it cuts deep. With so many stars, with so much time, why hasn't any civilization left a trace? Even if intelligent life were rare, the universe is old enough that just one successful species could have spread across a galaxy by now. Galaxies are not infinite. Crossing them would take millions of years, but millions of years are a blink in cosmic time. If someone had started long ago, we should see them, yet the skies are empty. No great fleets, no engineered stars, no beacons flashing across space. When we turn our radio telescopes outward, we detect pulsars, quasars, and cosmic background radiation, but nothing artificial. Scientists call this gap between expectation and observation the Fermi paradox, and every quiet night it sits there, unresolved. The silence itself can be strangely haunting when you sit with it, because silence in a place where you expect noise feels unnatural. Imagine walking into a busy train station at noon and finding it deserted, every bench empty, every track still. The lights are on, the architecture stands, but no voices, no footsteps, no announcements echo across the hall. That is the sensation the universe gives us. The infrastructure is there, but the traffic is missing. Some people argue the silence is simply a matter of scale. The universe is vast, signals weaken with distance, and maybe we haven't looked long enough or with sensitive enough tools. Our search is only decades old, a blink compared to cosmic timescales. The radio sky is enormous, and humanity has sampled only a fraction. It is possible that civilizations exist, but their signals have not yet crossed our path. Or perhaps they use technologies we cannot detect, signals outside the narrow bands we monitor. If that is the case, the silence is not a filter, it is simply a mismatch. But others point to the troubling possibility that silence is not an accident. It might be the natural state of the universe. Civilizations may burn out too quickly to be noticed, or perhaps they deliberately hide, avoiding the risk of attracting attention. Remember the dark forest idea. If everyone fears predators, everyone stays quiet. The silence may be the sound of caution, a cosmic agreement to whisper rather than shout. It is worth reflecting on how humans have added to the silence. In the early decades of radio, Earth leaked signals constantly. Television broadcasts, military radar, chatter spilling into space. If someone nearby were listening, they might have caught faint echoes of human activity. But as technology improved, our signals became more efficient and less leaky. Fiber optics carry information underground. Satellites beam tightly focused transmissions. Paradoxically, Earth is becoming quieter to outsiders even as our technology grows. If every civilization follows this path, the universe may be full of intelligent worlds, each wrapped in its own cocoon of silence, invisible to one another. There is also the question of visibility in another sense. Civilizations might not leave grand, galaxy-spanning empires. They might not build structures so large we could detect them. They might prefer small, efficient, sustainable societies. To an outsider, such civilizations would be nearly invisible. Silence would not mean absence, it would mean subtlety. In that light, the universe could be teeming with life, and we simply lack the right lens to notice. But silence has another psychological effect. It forces you to confront loneliness. On Earth, wherever you go, life surrounds you. Forests teem with insects, oceans with fish. Even barren deserts have lizards, cacti, and microbes. The idea that the entire cosmos might be barren, that Earth is the lone island of awareness in an endless sea, can feel unbearable. The silence might be less about absence of sound and more about the weight of solitude. This is why scientists keep listening. Projects like SETI, the search for extraterrestrial intelligence, have scanned the skies for decades, hoping for even a faint signal. They have catalogued countless natural phenomena, but so far, nothing artificial. A few blips have caused excitement. The "wow" signal detected in 1977, for example, but nothing repeatable, nothing confirmed. The silence holds. Sometimes, silence teaches as much as noise. It tells us about our own expectations, our own longing to not be alone. The silence may remind you that intelligence is rare, or fragile, or fleeting. It may remind you that even if life thrives elsewhere, its priorities might be so different from ours that communication is meaningless. A whale song drifts through an ocean, filled with patterns, rhythms, and meaning, but to a bird overhead, it is only muffled noise. What if the same is true for civilizations? Signals may pass through space, but we lack the ears to hear them. The irony is that while we search outward, we are also leaving behind our own faint traces. Every message, every probe we send, is a whisper into the dark. The pioneer plaques, the Voyager golden records, tiny attempts to announce ourselves. They float now, drifting in interstellar space, carrying greetings from a civilization that may or may not endure long enough for anyone to find them. They are part of the silence too, waiting. As you lie back and listen, think of this paradox. The universe is vast, ancient, and filled with possibilities, yet wrapped in quiet. That quiet may be telling us something profound about the nature of existence. Or it may be nothing at all, just the result of limited tools and limited time. Either way, the silence holds a strange power. It invites you to imagine, to wonder, to question. And so the unanswered question lingers. Is the silence of the stars, the sound of emptiness, or the sound of civilizations hiding, failing, or retreating beyond our view? When you look up at the night sky, every star you see is a messenger from the past. The light reaching your eyes tonight may have left its source hundreds or even thousands of years ago. If you could look deeper, beyond what your eyes allow, you would see galaxies whose light began its journey millions, even billions, of years earlier. Astronomy, in many ways, is not the study of what is, it is the study of what was. And within that delay lies a clue to the great filter. The universe itself is old, roughly 13.5 billion years. Earth, by contrast, is about 4.5 billion years old. For most of that time, our planet was lifeless or inhabited only by microbes. Complex life emerged only recently, in the last few 100 million years. Civilization, the kind that builds cities, telescopes, and radios, has existed for barely 10,000 years, a blink in cosmic terms. Our technological society, the one capable of sending signals into space, has existed for little more than a single century. Place that next to the universe's timeline, and it feels less like a presence and more like a spark. Now, imagine other civilizations scattered across the galaxy. Some may have risen 1 billion years ago, others 500 million. Some may still be microbes, others may already be gone. If civilizations appear and disappear across this vast timeline, the chance of two existing at the same time and overlapping long enough to notice one another shrinks dramatically. The universe may be full of voices, but if they are separated by time, they never converse. Think of it like tuning an old-fashioned radio. Signals come and go, drifting in and out of static. For a brief moment, two voices might overlap, but mostly they pass like ships in the night. Civilizations may flare into existence, send out faint whispers, and then vanish before another civilization reaches the stage of listening. The silence we hear could be nothing more than mistiming. There is a melancholy beauty in this idea. Picture an alien society, perhaps on a lush, water-rich planet orbiting a yellow star. They rise from their caves, map their skies, build their cities. Perhaps they invent mathematics, philosophy, art, and music. At some point, they point antennas skyward and wonder, just as we do if anyone is out there. They send signals, but no one answers. They wait for centuries. Their civilization may even collapse before ours is born. We never overlap. Their brief flame leaves no trace for us. It reminds you of human history in a way. Countless empires have risen and fallen on Earth, each leaving ruins but also gaps. The Library of Alexandria burned. Countless manuscripts were lost. Civilizations collapsed into silence before others could learn from them. Scale that up to the galaxy, and you have entire histories blinking in and out, their signals lost to time. Timing also explains the silence of the present. We may be too early. The galaxy is still young compared to the universe as a whole. Maybe civilizations are rare, and the chain of cause and effect needed to create them takes longer than we think. Perhaps the first true wave of civilizations is only beginning, and we are among the pioneers, If so, the silence is not permanent. It is just the quiet before the orchestra begins. Or perhaps we are too late. Civilizations may have peaked long ago and then vanished, leaving behind only uninhabited planets, stripped resources, or subtle ruins we cannot yet detect. If life burned brightly 1 billion years ago, all we see now are echoes of a fire already extinguished. That idea carries a strange loneliness with it. The thought that the galaxy may once have been alive with voices, but now only Earth remains. Consider how fragile our own timeline looks. We have had radio for just over 100 years. In that time, we nearly destroyed ourselves with nuclear weapons. We continue to reshape the climate in ways that could make our civilization less stable. Technology brings opportunity, but also risk. How long does a technological civilization last? 1,000 years? 10,000? Compared to the billions of years behind and ahead, those spans are vanishingly short. And if the average civilization lasts only a short time, then overlapping windows shrink even further. The odds of two civilizations being alive, advanced, and broadcasting at the same moment may be close to zero. You may feel the silence less as a mystery and more as inevitability. Timing also influences the way we search. Our telescopes capture only a thin slice of the electromagnetic spectrum, only for as long as we've had the patience to listen. A signal could have passed Earth 50 years before we built our first radio dish, or might pass 50 years after our attention drifts elsewhere. Missing it would be easy, almost guaranteed, like watching a single grain of sand fall through an hourglass and expecting it to reveal the whole pattern. Yet there's a quiet wonder in that fragility. It reminds you how rare and delicate it is for two voices to meet at the right time. Even on Earth, think of how many lives pass without intersecting. You walk through a city of millions and exchange only a few words. Multiply that across galaxies, across epochs, and silence feels less like a puzzle and more like the natural state of things. Still, there is a counterweight. Even if civilizations are brief, what about those that endure? A handful might last millions of years. One civilization, if it survives long enough, could eventually spread across its star system, its galaxy, perhaps more. And if even one civilization manages to endure, its footprint should be visible. That brings us back to the paradox. If time filters most civilizations out, where are the exceptions? Why do we not see the ones that lasted? It may be that survival itself is rarer than we want to admit. Civilizations might fall to their own mistakes, to resource exhaustion, to natural disasters, or to cosmic accidents like asteroid impacts. Endurance may not be the default, it may be the anomaly. If so, then silence is simply the arithmetic of time. Too many civilizations that burn bright and vanish. Too few that last. There is something oddly comforting about seeing our place this way. Humanity may not be failing to connect. We may just be early or late. Perhaps the silence is temporary, and in the far future, when civilizations have had more time to rise and stabilize, the galaxy will hum with voices. We may never hear them, but others might. So, as you lie back and listen, think about time not as a steady march, but as a rhythm, a cosmic dance of beginnings and endings. Civilizations may be like notes in a melody, sometimes overlapping, sometimes missing, sometimes arriving too soon or too late. The silence between notes may not mean the music does not exist. It may mean the song is larger than we can yet hear. And that brings you to the question that lingers long after the lights are off. Are we out of sync with the rest of the universe, destined to listen forever in the quiet, or are we simply waiting for the moment when another voice, by chance, lines up with ours? You might imagine that once a civilization reaches technology, it is unstoppable. Rockets launch, cities gleam, satellites orbit. Yet history and logic suggest otherwise. Technology is a double-edged sword. It offers the ability to survive, explore, and thrive, but also the ability to destroy, sometimes faster than intelligence or social cohesion can manage. The great filter may be waiting in the very tools a civilization develops. Consider humanity. For most of our existence, we survived as hunter-gatherers, small in number, low impact, and closely tied to our environment. Civilization changed that. Suddenly, humans could manipulate nature on a grand scale, grow populations, and concentrate energy in cities. With that power came a new fragility: machines, energy grids, and technologies that extend life and knowledge also introduce risks that didn't exist before. The same rocket that carries satellites can carry warheads. The same chemistry that cures disease can create bioweapons. Civilization becomes a delicate dance, balancing capability against the danger it brings. Self-destruction is not just a matter of intention, it can also arise from unintended consequences. Climate change is a prime example. Industrial society, with its focus on growth and convenience, has altered the planet's atmosphere. Rising temperatures, sea levels, and extreme weather events may not obliterate humanity overnight, but they destabilize economies, ecosystems, and societies. Slowly, perhaps imperceptibly, these pressures could fracture civilization. Past societies have collapsed from similar pressures, albeit on smaller scales. Mesopotamia's salinized fields, the Mayan droughts, the fall of Easter Island society all illustrate how complex systems can fail when environmental changes outpace adaptation. Nuclear weapons add another layer of peril. For the first time in history, humans can end a civilization, or even a species, in hours. During the Cold War, the balance of terror relied on mutual understanding and restraint. One miscalculation, one system failure, one misread signal could have triggered global catastrophe. History shows us that near misses are not rare. Each close call represents a moment where the great filter might have intervened. One wrong decision could have ended everything. Technology also accelerates the pace of change. Rapid innovation is a double-edged sword. It allows societies to adapt faster, but it also introduces new risks faster than societies can fully understand them. Biotechnology, artificial intelligence, nanotechnology, each holds enormous potential but also unprecedented dangers. A civilization capable of interstellar communication may also be capable of erasing itself with its own creations. The question is not if the tools exist, but if wisdom and governance can keep pace. History provides lessons. The collapse of civilizations is rarely a single event. It's often a slow, compounding process. Systems break down quietly until they fail spectacularly. Trade networks fail, political systems fracture, trust erodes, diseases spread unchecked, resources are depleted, civilizations fall when complexity exceeds their ability to manage it. If the great filter lies here, it is not a sudden cosmic obstacle, it is a creeping risk that accumulates unnoticed until it is too late. Yet the pattern is universal. We can imagine alien civilizations, somewhere in the Milky Way or beyond, facing similar dynamics. They too invent technology before mastering restraint. They too must balance energy, growth, and cooperation. For all their intelligence, they might stumble at the same hurdles we face, their advanced cities and knowledge collapsing quietly into oblivion. The silence of the cosmos might simply be the result of repeated self-destruction across billions of years. Even the tiniest misstep can matter. Imagine a civilization that colonizes planets within its star system. If it mismanages resources, triggers a chain reaction of environmental damage, or unleashes a technology it cannot control, the entire system could collapse. The larger and more advanced a civilization becomes, the more it risks. In this light, survival is not about strength or intelligence, but about careful adaptation, foresight, and perhaps a bit of luck. The great filter in this context becomes a warning rather than a mystery. It asks, can intelligence coexist with power without annihilating itself? The longer a civilization survives, the more fragile it may become, because each new technology multiplies the consequences of error. The universe may be full of civilizations that reached this point and failed. Perhaps their silence is less a mystery of distance and more a record of failure. And yet, there are signs of hope, subtle but real. Humanity has survived near misses, adapted to environmental shifts, and created systems of cooperation that span continents. Knowledge accumulates. Scientific discovery allows anticipation of problems before they reach catastrophic levels. Unlike past societies, we have global awareness. Satellites, computers, and networks let us track climate, disease, and conflict in real time. Perhaps this ability to anticipate, to see risks early, is our chance to navigate past the filter that destroyed countless civilizations before us. But it is also a race against time. The longer we delay meaningful action, the more technology we accumulate, and the more opportunities for disaster arise. Each advancement adds both power and peril. Civilization is like a tightrope walker. One misstep can be fatal, but cautious balance can allow survival, and the universe remains silent, as if waiting to see which path we choose. Self-destruction is therefore not just a possibility. It may be the primary filter, preventing civilizations from spreading across the stars. Advanced societies may often exist for brief windows before vanishing. Those that endure are exceptional. The universe may be full of almost their civilizations, stopped by their own hands, their voices fading into cosmic background noise before they can reach one another. The lesson is humbling. Civilization is not guaranteed. Intelligence is not an insurance policy. Power without wisdom is fragile, and survival may depend on decisions so subtle and interwoven that even minor errors cascade into catastrophe. Every choice in governance, technology, and resource management carries significance far beyond its immediate effect. The filter may not be a distant obstacle, but a daily challenge. And as you lie back, drifting toward sleep, consider this. The silence of the stars might be telling us a story of caution. It may remind you that intelligence is rare not because it is impossible, but because it is perilously easy to destroy. Civilizations may rise, create wonders, reach toward the heavens and yet vanish, leaving only faint traces or none at all. Humanity's window is fragile, precious, and not infinite. So the question remains, will we survive our own capabilities, or will the great filter strike in the form of our own choices, turning brilliance into silence once again? When you look up at the stars tonight, you might imagine a peaceful cosmos. Planets orbiting quietly, stars burning steadily, space stretching endlessly. But the universe is far less tranquil than it seems. Across its vast expanses lie hazards invisible to casual observation. Supernovae, gamma-ray bursts, rogue planets, asteroid swarms, and radiation storms that could sterilize entire worlds. These cosmic phenomena are not fictional, they are the natural workings of physics, and they may be part of the great filter. Take supernovae, for example. These are stars that explode at the end of their lives, releasing enormous amounts of energy in seconds. A supernova within 30 light years of a planet could strip away the atmosphere, destroy the ozone layer, and bathe the surface in lethal radiation. Civilization, no matter how advanced, would struggle to survive such an event if it happened unexpectedly. The Earth has been fortunate so far, with no nearby supernovae occurring in the last few million years. But the odds are never zero. Even more powerful are gamma-ray bursts, which can release more energy in a few seconds than the sun emits in its entire lifetime. These bursts are directional and rare, but a single beam pointed at a habitable planet could destroy its atmosphere and trigger mass extinction. Imagine civilizations thriving on distant worlds, only to be wiped out in moments by a cosmic death ray they could never anticipate. The universe is vast, but it is also indifferent. Survival is never guaranteed. Rogue planets pose another hidden threat. These are worlds ejected from their star systems, wandering the galaxy in darkness. If such a planet collided with a habitable world, it could cause global devastation. Even smaller objects, asteroids, comets, or icy bodies, have the potential to reset civilization in an instant. Earth itself survived a planet-altering impact 65 million years ago, the asteroid that ended the age of dinosaurs. That impact opened the way for mammals to flourish, ultimately allowing humanity to exist. But similar events could also end civilizations before they ever become interstellar. The sheer scale of space compounds the problem. Galaxies are crowded with hazards that appear random but have profound consequences for life. Stars move, orbits shift, and cosmic radiation varies. A planet safe today might be exposed to deadly events in a few million years. Civilizations may arise, thrive for a few thousand or 100,000 years, and vanish simply because the universe is not perfectly predictable. Cosmic timing can be a filter, as lethal as any self-inflicted mistake. There is also the danger of nearby stars. Some stars are highly unstable, prone to flares, eruptions, or gravitational disruptions. Imagine a civilization orbiting a volatile star, confident in its sun's stability, only to face a sudden eruption that batters its planet with radiation and charged particles. Habitable zones are not permanent. They shift over time. Even planets orbiting quiet stars may face catastrophic changes in their environments, threatening complex life and technological societies. Black holes, too, pose subtle but real risks. While the nearest known black holes are far from Earth, imagine a civilization orbiting closer to the galactic center, where stars cluster and gravitational dynamics are more chaotic. Rogue black holes or wandering stellar remnants could destabilize planetary orbits, sending worlds into freezing darkness or into their suns. Cosmic hazards are not always violent in an obvious way. They can be insidious, slow-moving threats that appear out of nowhere. The Great Filter might also hide in phenomena we do not yet fully understand. Cosmic rays, background radiation, or unknown energetic events could subtly damage DNA over time or interfere with complex systems. Perhaps some civilizations face invisible, cumulative threats that slowly undermine life before technology can protect against them. The universe may harbor dangers that are invisible until they strike, creating quiet but absolute barriers to survival. Even the most advanced civilizations may struggle to mitigate these hazards. Spacecraft can survive radiation for short durations, but entire planets cannot be moved or shielded easily. Global warning systems and evacuation plans could save small populations, but a truly planetary threat, supernova, gamma-ray burst, or massive impact might be unstoppable. In this sense, cosmic hazards act as impartial filters. They do not favor the intelligent, the resourceful, or the technologically advanced. They simply strike wherever the physics aligns. And yet, life is stubborn. On Earth, microbes survive extreme radiation, high pressures, freezing temperatures, and deep-sea darkness. They endure through mass extinctions, climate shifts, and asteroid impacts. Civilizations that arise from such resilient life may have ways to protect themselves: space habitats, planetary shields, or interstellar migration. But these measures require foresight, resources, and time. Not every civilization can recognize cosmic risks in advance, let alone survive them. The universe may eliminate most before they reach the stage of cosmic awareness. There is also a subtle interplay between cosmic hazards and the emergence of intelligence. Life may exist widely in the universe, but intelligent civilizations may only appear where hazards are minimal. Perhaps Earth is unusually fortunate, orbiting a quiet star at a safe distance from galactic hazards, in a stable neighborhood of the Milky Way. If so, the Great Filter is partly environmental. Most planets never provide a safe enough context for life to reach intelligence. In that sense, the silence of the stars may reflect the harshness of cosmic geography as much as the fragility of civilizations. The scale and randomness of these dangers are hard to comprehend. Millions of planets, billions of stars, countless events. Yet survival requires avoiding them all or mitigating their effects. If even a single critical hazard strikes a civilization too early, it disappears, leaving only cosmic silence behind. Perhaps this is why we see no megastructures, no signals, no traces of interstellar neighbors. They exist only briefly, and then the universe reclaims its silence. And yet, this quiet threat holds a peculiar beauty. It emphasizes the fragility and preciousness of life, of consciousness, of civilization itself. The Earth has endured billions of years of cosmic danger, giving rise to you, to your ability to think, wonder, and gaze at the stars. That survival, improbable as it is, may be rare even in the vast cosmos. Cosmic hazards are not meant to punish, they simply exist. Survival is not owed. It is earned by persistence, adaptation, and perhaps a little luck. So, as you lie back and drift towards sleep, imagine the universe as a grand, indifferent stage. Stars blaze, planets orbit, radiation pulses and impacts occur, all without care for the tiny sparks of life they encounter. Civilizations may flare into existence, shine for a moment, and then vanish without leaving a trace. The silence of the cosmos may not be mysterious. It may simply be the natural consequence of enduring an indifferent, dangerous, and beautifully vast universe. And the question remains, if cosmic hazards are real, how do we, a single civilization on a small blue planet, navigate them? Are we already unusually lucky? Or will the universe one day remind us of its impartiality? Intelligence is the hallmark of civilization. It is the spark that allows a species to manipulate its environment, to create tools, to explore, and to imagine. Yet intelligence is also a paradox. The very trait that can elevate a species may also carry the seeds of its destruction. The great filter may not just be a distant obstacle or a cosmic hazard. It may reside within the minds of civilizations themselves. Think of intelligence as a double-edged sword. On one edge lies problem-solving, innovation, and foresight. On the other edge lies hubris, overreach, and unforeseen consequences. Every discovery opens new possibilities and new dangers. Humans, for example, developed fire, agriculture, metallurgy, and machines. Each advancement increased our control over the world, but also introduced new vulnerabilities. Fire could burn homes, agriculture could exhaust the soil, metallurgy could produce weapons, and machines could magnify errors. The more intelligent a species becomes, the greater the scale of both its achievements and its potential failures. Consider language and culture. These uniquely human tools allowed cooperation, the transfer of knowledge, and the creation of complex societies. Yet they also introduced conflict. Disputes over resources, ideology, or power can escalate into wars capable of wiping out millions. Intelligence gives us foresight, but it also gives us the ability to plan destruction on scales unimaginable to non-intelligent species. Civilization is a constant balance between cooperation and competition, creation and destruction. Intelligence also allows prediction, but never certainty. A species may calculate the effects of its actions, model its environment, or simulate future scenarios. Yet complex systems, climate, ecosystems, even societies contain feedback loops and variables beyond complete control. Decisions made with the best information can still trigger catastrophic consequences. The very act of thinking ahead creates a tension between possibility and risk. Intelligence does not guarantee survival. It merely gives the opportunity to navigate danger. This duality is evident in our own history. Take nuclear weapons. Humans discovered the principles of nuclear fission in the 1930s. By the 1940s, they had built bombs capable of ending civilizations in hours. Intelligence created both the knowledge and the means of annihilation. Yet wisdom, the restraint, foresight, and ethical guidance necessary to manage such power developed more slowly. For decades, humanity survived by a combination of caution, diplomacy, and frankly, luck. Intelligence provided the capability, but survival required careful judgment. Even more subtle are the unintended consequences of intelligence. Technology amplifies scale. Small mistakes or miscalculations can cascade into civilization-threatening events. A single pathogen accidentally released in a lab could spread uncontrollably. A mismanaged environmental decision could trigger climate shifts. AI or autonomous systems could act unpredictably. Intelligence creates these possibilities precisely because it allows manipulation of the world on an unprecedented scale. Survival is not automatic. It is a fragile outcome of knowledge applied wisely. Now imagine alien intelligence. On another planet, a species may evolve the ability to think abstractly, to manipulate energy and matter, to communicate across distances. Once they reach that point, their own intelligence becomes a filter. A civilization may develop energy sources, industry, and global networks, yet fail to anticipate the systemic risks of their creations. They may achieve remarkable progress, only to collapse under pressures they could have foreseen but did not fully manage. Intelligence is a tool, but like any tool, it can be misused, misunderstood, or outpace the species' wisdom. There is also the question of ethics. Intelligence allows reflection on right and wrong, long-term consequences, and collective responsibility. But ethical systems are not automatic. They evolve slowly. A species may develop the technical means to prevent self-destruction, but fail to adopt the ethical frameworks to use those means wisely. The great filter could reside in the gap between capability and ethics. Civilizations that bridge that gap survive. Those that do not vanish. Intelligence also creates curiosity, a drive to explore, to expand, to probe the unknown. That curiosity is what might one day allow a civilization to colonize space, send probes across galaxies, or communicate with others. Yet curiosity can also be dangerous. Exploration without caution can trigger conflicts, reveal hazards, or expose the species to new risks. The very trait that allows survival can also accelerate collapse if wielded without care. Interestingly, intelligence can even become self-reinforcing or self-limiting. Civilizations that survive tend to increase their intelligence collectively, building institutions, sharing knowledge, and accumulating wisdom. But this same process can make them brittle. Dependence on complex systems, over-specialization, and reliance on technology can make a civilization vulnerable to collapse. A minor disruption in critical systems, energy, food, communication, can cascade rapidly, threatening survival. Intelligence amplifies both resilience and fragility. Consider the implications for SETI, the search for extraterrestrial intelligence. When we look for intelligent life, we often think of advanced technology, radio signals, and visible civilizations. But intelligence may be a bottleneck in itself. Only civilizations that navigate their own intellectual, ethical, and technological pitfalls survive long enough to leave detectable traces. The silence we hear could reflect the filter operating internally. Species that reach intelligence often eliminate themselves before reaching interstellar maturity. Even intelligence is not uniform across a civilization. Subgroups may act in conflict, undermining collective survival. Decisions made by a few individuals can influence the fate of billions. History is full of examples where powerful knowledge was misapplied, creating vulnerability. Civilizations that survive the Great Filter may be those that align intelligence with cooperation and foresight, maintaining stability across generations. Those that fail are erased, leaving no trace. There is a quiet lesson here for humanity. Our intelligence is remarkable, allowing us to reflect on the universe, to design technologies beyond imagination, to explore both the macroscopic and microscopic worlds. Yet that same intelligence can create threats invisible until they are nearly inevitable. The Great Filter may reside not in stars, chemicals, or distant hazards, but in our own capacity to think, decide, and act wisely. Intelligence is both our shield and our potential undoing. As you drift into the quiet, Imagine the universe filled with other intelligent minds. Some may have reached incredible heights, only to falter under the weight of their own cognition. Others may survive, having mastered the delicate balance of wisdom and power. The silence we perceive may not be emptiness. It may be the echo of intelligence, succeeding or failing across the cosmos, a hum of civilizations that shine briefly before fading. And so, you must ask yourself, will our intelligence guide us past the filter, allowing us to endure and explore? Or will it be the mechanism that ensures we, too, become a quiet memory among the stars?